Hi, I'm Saikripa Purushothaman, Data and Analytics Consultant with Thurbit. Today, we will cover the fourth and the final part of the series, the stages of your analytics journey, where we will discuss about the measuring success of a machine learning solution. When we define success, it's important we consider two aspects, model or the statistical performance and the business performance. Statistical model output gives more accurate, meaningful results, whereas these results are then acted upon to get desired business outcomes. Can a model be successful in a business sense without being successful in a statistical sense? It might be hard to find how, initially, a model is never going to be perfect, and it doesn't have to be perfect to be useful. It depends on the question or the scenario. For example, directing tickets in a support queue to the right person. Maybe the current process is that they randomly assign the tickets to different persons, and using machine learning, if we can direct 50% of the tickets to the right person the first time, that could be a big savings in terms of effort and a big improvement in terms of the customer service metrics. Even though 50% doesn't initially seem like a great hit rate. On the other hand, there are plenty of times where we need high accuracy for models to be useful. Not 100%, but high enough to beat robust processes that we already have in place. Another example would be used to take rating insurance policy. If we wildly underestimate the risk in some cases, there'll be a major cost to the business for getting that decision wrong. So, as is often the case, it depends as to how exactly we measure the machine learning model success. Let's hold that thought. We will come back to it when we discuss how to measure business successes. But first, let's take a look at some of our options in terms of measuring success from a statistical perspective. From a statistical perspective, we use evaluation metrics to measure the machine learning model performance. There are different metrics for these, and some of them are called accuracy, precision, recall, and it all depends on the model that we build. For example, if you're examining a patient for a certain medical condition using an ML model, it may be okay to identify a healthy person as someone with a medical condition, wherein a subsequent test will figure out or confirm the medical condition. But at the same time, if the model identified a person with the medical condition as healthy, then that's disastrous. Identifying a healthy person as the one with the medical condition, we call it false positives, whereas identifying a person with the medical condition as healthy, we call it a false negative. When you cannot afford to have any false negatives, you prioritize the metric called recall. On the other hand, if you're recommending movies, it is kind of okay to kind of miss out on recommendations of a particular movie that the user would be interested in. But at the same time, it's not so okay to kind of show irrelevant recommendations that the user may not be interested in. In such cases, you prioritize a metric called precision. To get an understanding of the models early on, what we can really do is to test the model against the training data set. This will serve as a very early indicator as to how the model is performing. As a second step, later on, what we could also do is to try and understand how the real data set or that new data is actually different or compares to the training data set. The new data is different from the training data set. It is more likely that the model may not give you the expected results. Not 100%, but very likely. We will then need to understand the new patterns and tweak the models to get the accurate results. Further on, when we move on, it'd be a good idea to kind of compare the predictions against the actual observed data. That will give you an indication on how well the model has predicted. Has it predicted correctly or not? And this will help you understand with greater certainty the model performance. Moving on to evaluate business performance, how do we translate the model output to business goals? First, we need to define a goal for our business. What do we want to achieve with the model? How is your model making the business money? The true measure of model success is how it impacts the business. So, how can we measure the success in terms of business performance? For example, if the business goal is to increase the revenue of a product, so we need to evaluate the ML model against the revenue metrics to determine if the model has really helped. Some of the ways to understand the success of a model are: attach a value of business metrics. For example, if a particular store is taking recommendations for my products, then fix a value to the revenue they are expected to generate. Evaluate this value against the actual revenue metrics. The second way is probably to track how decisions are affected by the ML model outputs. Are the recommendations derived from the model metrics actually changing purchase patterns and hence increasing revenue? We could use tools and surveys to get an understanding of the changes in the business or purchase patterns, leading to a positive change in the revenue, and that will help determine the model's success. On the other end, we can compare the history KPIs with the current ones to understand how it has impacted the revenue changes. We might want to limit the recommendations to a certain subset or a control group to experiment the model and understand the changes. For example, if we are making changes based on recommendations only to a subset of the stores in the region and understand the purchase patterns and the revenue against the remaining stores outside the subset. In the end, if the model performance is poor, the business performance will not be at the expected levels. But the business performance itself is a function of many variables. So good model performance does not guarantee a good business performance either. Moving on, we talked about two ways of measuring success of an ML model. There are two other ways that are currently a hot topic in the market and is equally important as well. And these are explainable AI and ethical AI. Explainable AI is a set of processes and tools that enables humans to understand the decisions and the predictions done by an ML model. What it really means is that it kind of helps users to trust the model because they understand what's going on behind the scenes. Ethical AI, on the other hand, is a set of principles that we expect the ML model to follow. As simple as, not basing its decisions on any biased, if it's any preferential treatment to any specific category. As simple as a gender bias, male versus female, if it's predicting anything that focuses on one of the genders. On the other hand, another example would be is to build any AI model or any AI related system that puts humans' well-being as the highest priority. With this, we conclude this video. I hope this short series was a good eye-opener for you in terms of understanding how to kind of progress with the ML journey. Please feel to reach out to us or any of us who we have seen in this series to kind of understand any of these topics more or to understand how to use your organizational data effectively. Wishing you all success with your ML journey. Thank you.